specific formula for it. Meaning, like we did equilateral triangles yesterday and they had a formula. Hexagons had a formula. Okay? This is pretty much dealing with any other situation. And just to remind you, right, we had all this yesterday. But all the formulas we're doing today, when we're doing area of these shapes, it's area of regular polygons still. It's the same thing. We're going to cover the same thing on Tuesday. It's still, like everything we're doing today is going to be focusing on the 1/2 AP formula. So that means we're going to have to do some work to find perimeter. If they don't give us a side length, even if they do, we still have to do the n times s thing. Or we're going to have to do some work to find the apothem. Okay, so today it's not going to be, they're not going to flat out tell you here's the apothem, here's the side length. You're going to have to find it. Okay, and the reason that you can find it is because we have stuff to find this angle measure in there, right? That was the central angle. We did that yesterday. All right, and then we got the stuff from last chapter with all the right triangles, right? The sine, cosine, tangent to find side length. That's what sine, cosine, tangent was used for, to find sides of a right triangle. So since we have all that, I can give you just a couple measurements and you can find everything you need to plug into that formula right there. Okay, so the problems are a little bit longer because you do have to take the time to find those. But if you keep it all nice and organized, they really aren't that much more difficult. They're going to look more difficult because of the amount of work you're doing and for the way the numbers look and stuff. But as long as you keep it nice and neat and organized, the problem shouldn't be that much more difficult. Okay? All right, so point out a couple things before we do some problems. Okay, so problems today, obviously you're not going to have a circle around it. This just has it to represent, to remind you that the 1 and 1 that's up there, that's the radius. And I'm not actually going to find the area of this. This is just to show you what parts we're looking at. But if I did give you this problem and I say find the area of that regular pentagon, I don't have a formula for yesterday, like a special formula, like there's no equilateral triangles in this, it's not a hexagon. So that means since it doesn't fit any of the special ones from yesterday, I have to do the 1/2 AP thing for it. All right? And if I look at it, I don't have a measurement on the apothem there, which I need, right? Because the formula for it was 1/2 AP, so I need that line, which is this one. Okay, so that doesn't exist. And for the perimeter, I need the side length. So since neither one of those exists, I would have to approach this as knowing I need to work within these right triangles there to find out what those measurements are. Okay, and that's going to be where the sine, cosine, tangent comes into play. And the whole idea behind this is I'm going to find the area of this triangle, essentially. Okay, because I said yesterday, right, the 1/2 AP is essentially 1/2 base times height. Okay, and the height's the apothem, and the perimeter is the base of all of them together. But what you're doing is you're finding essentially the area of that triangle and just multiplying it by 5. There's 5 triangles. Okay? So, as you go through breaking it down, all right, your focus will change from the entire polygon, right, to the triangle with 2 radii in it. All right? And then your focus will essentially come down to 1 right triangle. Okay, now what I have labeled up there, guys, that setup is always going to be the same. This angle right here that they have is 36. That's always 1/2 of the central angle. Right? And remember, central angle meaning central angle was 360 over n. So if I do, in terms of this problem, if I do that, it's 360 divided by 5, which was 72. After 72 gave them the 36 that they have labeled right there. That angle at the top is always going to be the one that you can find quickly. Okay, so you can either write this as 1/2 the central angle, or you can go ahead and write 180 over n. Same things happen. Okay, because half of 360 is 180. That's why I'm putting it there. So this angle is always going to be the one you find. In terms of us doing right triangle stuff, guys, that's the one you're going to focus on. So since like, as I set this up, that's going to be the angle I'm focusing on. That means that this side right here that has the R on it, that's the radius. That's always your hypotenuse. The apothem, the A, that's always your adjacent side. And this measurement here, it's always the opposite. Okay, and the reason you can leave that label that way is this is going to be the angle measure that you find. So I'm always going to be looking at that angle. Okay, and what these are, this side will always be the apothem, that will always be the radius, and that will always be 1/2 of the entire side because I'm only looking at one of these right triangles. So this side right here is the 1/2 side. Now, out of the three sides, the two you definitely have to do an area problem are this one here, because the 1/2 AP, the apothem, is part of that formula, and then you have to have this side. Okay, if you don't know the radius, it's not a big deal in terms of the whole area problem, because the radius is just used maybe to find this length. Okay, so like I said, the main focus comes back to that right there. All right. Now, as we do the problems, guys, not every single one of these are going to be drawn out, and it honestly is not a big deal whether or not you have the actual polygon drawn out, because the work you do is with this triangle. So when I'm checking work, guys, and I'm looking for things, I expect this triangle to be set up. Because what it really comes down to is a problem from the last chapter that would have said, solve this right triangle. That's what it comes down to. So if you're doing work and you don't get the right answer, you don't know what to do, and I don't see this drawn out, I know you're not like either paying attention here, or you didn't write something down, or you're just like kind of doing whatever right now. This needs to be there. Okay, because this is going to be the work. If the drawing's there, if the polygon's drawn, you want to do all the work here, fine. I don't care, as long as I see you have these things labeled the right way. All right. So, I'm going to go through probably on 2 or 3 of these. I'm going to have you guys do a couple. Okay. All right. So, let's do the first one. Okay, and I'm just sticking with the pentagon because we just had. Write the numbers up. Okay, what I'm going to do is I'm going to redraw that right triangle that we had, best I can, and just label it so I can work on a bigger triangle. Okay, so in terms of what I had things labeled, right, this was the 180 over n part. All right, so this was essentially 180 over 5. I know the 36 was already up there, but if it wasn't there, I would expect you to do 180 over 5 to equal to 36. That's my apothem. They have labeled as 4. That's a good thing. That's the radius, which is right that side right there. And this one right here, which I'll throw like an X on. Remember, this is always 1/2 of the side. All right, so if I gave you this problem and I said, what's the area of that regular polygon? Okay? Again, I'm just asking you to get the correct numbers to plug into that. Okay, now if I look at the formula, right, I've already got the apothem in this case. It's an easier one because they give you one on the side. So when I actually do the area formula, I can kind of already plug in one number. So I got 1/2 of 4 times whatever the perimeter is. So with a problem like this, all the work that I'm doing is going to focus on simply finding the perimeter. Okay, now which one of these two sides would I need to actually find the perimeter? The x, right? Because I need the side length to find the perimeter. So this is what I was saying, I really don't care about that radius thing. Okay, it has no bearing on the problem right now. I don't need to waste time finding it. All right, so say you can always focus on this angle, your adjacent side, that's your opposite. Right, so going back to the sine, cosine, tangent, which one uses opposite and adjacent? So when I set this up, and again, the whole purpose of me doing this is so I can find the side length, because the side length will in turn find the perimeter. So I'm setting this up as tangent, 36 degrees equals opposite over adjacent. Then how did I go about solving that out? What do I do? Tan 36 and then do what? Multiply by 4, right? So what's tangent in 36? 7265. 5 x over 4. And if I multiply that by 4, that gives me 0.9. So 2.9 will leave it there though. Okay, so here's what you gotta understand, guys. The 2.9 we just found is right there, this part. Okay? So one thing you have to remember is for me to do perimeter, I need the entire side length. So whatever number you get here, you're going to double it. Okay? Because both of those sections right here are 2.9. So what's 2.9? 5.8. So now that you have that doubled, you have the entire side length. So it means now I can do my work to find the perimeter. And the perimeter is just side length times the number of sides. How many sides are there? 5. So what's 5.8 times 5? 29. Okay, so I'm just going to put my 29 in there. And the last thing would be just multiplying those out. Like I've got my poplin now, I've got my perimeter, just 1/2 AP, just like you would have yesterday. Okay, you just have to do this little bit of extra work. So what's 1/2 4 times 29? 58. And there's no units here, so that's square units. Okay. All right. Can I move on, guys? The next one. Okay. What's the next? Like I said, you don't want to draw out the actual octagon. It really doesn't matter, okay, if you do or not, because again, if I'm finding area and perimeter of this, and I tell you it's a regular shape, I said you're always going to be setting up one triangle to work with, right? And guys, the setup, it's like always, it's the same. That's 180 over the number of sides. Which how many sides does the octagon have? 8. This side right here is always the apostles. And this side right here, which I'm putting the X on, is always 1/2 of the side of it. Okay, and that is the radius. All right, so the only thing I know right now is that they tell me the radius is 11. Okay, put 11 on it. There would be my triangle. Now all it becomes, me doing this problem, it simply becomes a right triangle problem from the last chapter, where you've got an angle measure, you have side length, and you find the other two sides using sine, cosine, tangent. Okay, and I said the setup's always the same. That's the angle you're focusing on. That's always the adjacent side. That's always opposite. Or it's going to be the hypotenuse. Okay, and again, we're working towards area and perimeter. So area is 1/2 AP. So I need to find the perimeter, and I need to find the hypotenuse. So this will be, if I give you the radius, these are going to be the longer problems because you need to find both of those measurements, as opposed to the last one where I just had to find one. Okay? What's 180 over 8? 2.5. Okay, so that's my angle I'm going to use with sine, cosine, tangent. Which part do you want to find first? Doesn't matter. You want to find the apothem or the half side? The x, the half side, okay. So if I go about finding this one first, right? That's my opposite side. Hypotenuse is given to you. Which one's opposite over hypotenuse? Sine. So you get sine of the angle equals x over 11.
What does it have to divide? So it's going to be 5.
I already did. And you do the 180 is already divided by.
All right.
If you do sine 22.5 times 11, you get 4.2. Okay. So now I've got, basically what I have, guys, is the half side. So if I were to draw this on the triangle here, or on the octagon, the part I have is right there. Right? So I got that part's 4.2, which means that part's 4.2, which means the entire side is how long? 8.4. Okay? Which means now that I have the side length, can I find the perimeter? Yeah. So the perimeter here would be 8.4 times 8, which is how much? 7.2. Okay? So I've got that now. I've got the perimeter part. That's done. Which also means that I can plug that into my area point. All right, so I don't have the apothem yet, but I have 67.2 right there. Okay, so now, here's the thing. You've got two options now. Since I have this as 4.2 and that is 11, I technically have two sides of the right triangle. So if I wanted to do Pythagorean theorem, I could, and get the third side. Or I could just do adjacent over hypotenuse, right? Because the apothem is the adjacent side. The hypotenuse is what's given to me. Which one's adjacent over hypotenuse? Cosine. If I'm doing these, I'm doing sine, cosine, tangent, because it's much faster. Pythagorean theorem. Okay. So to solve for this one, cosine 22.5 equals a over 11, right? You just multiply 11 by whatever that is, cosine 22.5, 10.5, 2. And then that'd be the whole problem, right? Because now I've got the apothem, I've already found the perimeter, you just got to take those, plug them into area point. Okay, so the area here is going to be 1/2, 10.2, and 67.2. What is all that multiplied together? 2.7. 3.7. Okay. The problems, guys, like I said, more work involved. And you're automatically going to think it's more complex. There are a lot of steps here. Stay organized. That's the biggest thing, staying organized. Okay? I'm going to do one more problem, and have you guys do a couple on your own, okay? Alright, so this is the next one. There's a drawing with it, just telling you, decagon, radius is 5. Okay? Now again, you can draw a decagon on your paper if you want. Have at it. Make sure it's 10 sides if you're drawing it out. But the whole idea behind this, guys, is if I'm asking you to find area, like, and that's what I'm just going to say we're going to do, find area. The whole idea is I just need to find the apothem and the perimeter, right, just like the last one. And I said, this right triangle you set up is always the same. This side is always the apothem. That's the radius. This side that I just keep throwing that X on is always 1/2 of the side length. Okay. This is always 180 over n. Okay. So it's just a matter of you remembering how that triangle is set up, and you throw in the appropriate numbers. Like a decagon has how many sides? Or men. So I know that angle measure that I'm going to be looking at is 18 degrees. All right? The radius there is 5. Okay? And this side is always your hypotenuse, right? That's always opposite. Alright, so this is back to the last problem we just did, where it's up to you. Do you want to find the half side first, or do you want to find the apothem first? Half side, the x? Okay, so just like the last one, that's still my opposite side. Starting with the hypotenuse, so when I do this, it's still going to be sine. Okay, sine of 18 equals x over 5. And guys, if you don't realize, if you set this up the same way every time, like the problems that start with the radius, you're always going to use sine to find the x, cosine to find the a. Alright? So what's 5 times sine of 18? 5? 1.5. Okay, so x is 1.5, that's half the side. Alright, so when I do perimeter here, my perimeter is going to be the entire side length, which is what? 3 times the number of sides, which is 10. So that is 30. Okay? Just like the last one, guys, cosine finds the apothem. 5 times cosine 18, 4.8. And that's all the work right there. Okay, I just got to take those numbers now, plug them into the area form. So I know my area is going to be 1/2, 4.8 times 30. So either do 2.4 times 30 or 4.8 times 31-ish.
Yeah. I didn't round up the.
Oh. Great. What did you get? 72. Just with the rounding. 72. And since this has units, I will throw. Okay, so all that work was to get the area. All right, so I'm telling you guys, look, if you're trying to do these, you aren't going anywhere with it, and I don't see that triangle drawn, that means you just zoned out for about the past 15, 20 minutes. You need to work with this triangle, guys. It's just simply, like these problems are nothing more than a right triangle problem. Okay? Because that right triangle is always going to solve for perimeter and apothem, which is what you need for area. Okay?